Hey tech enthusiasts, welcome back to Big Tech Interviews, your place for mastering SQL interviews. Today we're going to pull back the curtain on what it takes to be a data analyst or a data scientist at Meta, one of the world's leading tech giants. Imagine working on projects that shape the future of social media, connecting billions of people globally. From crunching massive data sets to delivering insights that give major business decisions a process, these roles are as exciting as they are challenging. And let's not forget, the salaries are pretty sweet too. Stay tuned to learn more about the salary that you can expect from the various roles and the skills that are going to be needed to ace the SQL interview. So let's discuss what roles require a SQL interview at Meta. These are going to be roles like data analyst, data scientist, and business analyst. These professionals play a critical role in interpreting data to drive key business decisions. They collaborate closely with engineers, product managers, and other stakeholders to provide insights that shape product development and strategy. So for the business analyst, typical pay range is going to be in the $140,000 to $230,000 range. Now that really depends. Coming in to start, you'll probably be at the 140 range. There's about $20,000 a year in additional pay. That can be things like bonuses, incentives, and such. The data scientist, that's a little bit more, requires a lot of math. So that's going to be around 200,000 all the way up to 90 sometimes. The base salary there coming in is going to be about 165, 170 a year, 170,000 roughly. Additional pay on that one can come in around 70,000 sometimes. It really depends on what projects you're working on. And then there's the data analyst, which is about 140,000 sometimes all the way up to 200,000, 205. A little bit, although base pay is going to be about 170,000 on that, with additional payment options around 30 to 35,000. So we'll talk about these three roles and go over sort of what is the role, what does it mean to be in the role, what are some common projects, the required skills to be in the role, and example tasks or what a day-to-day might look like for each one of these. So let's start with the business analyst. They work on identifying business needs, analyzing processes, and designing solutions that drive business improvements. They also bridge the gap between non-technical teams like operations and the technical teams like engineering. Some projects are going to be things like market analysis, process optimization, performance tracking. Basically, they use data to recommend strategies for improving the efficiency of the business and achieving those goals. You'll need strong analytical skills for one, that should be obvious. Proficiency in querying language, SQL, obviously. Data visualization tools are always handy because you'll want to render that information into data stories that non-technically minded, non-data minded people can interpret and make decisions off of. And in that respect, you'll need some communication skills as well, because you'll need to interface with those stakeholders and show them your findings and your results and explain it in a way that they understand and be able to answer the questions that they may have about it. They need to make a decision based on what you've presented. So an example task might be developing a dashboard that tracks the performance of different marketing campaigns or various key performance indicators about products, identifying strategies that yield the potential highest ROI, right, return on investment, and then using information like that and performance tuning and analytics to suggest areas of improvement. You may also be able to find ways that the business can operate a little more efficiently or at a higher production rate, that sort of thing. So the business analyst is really about understanding data, first of all, so that you can make a measurable, informed, evidence-based observation or conclusion, and then understanding the business so that you can go and interface with the people who are either generating that data or making decisions off of it, or both, rendering information in a way that makes sense to everybody so that key decisions can be made. All right, the data analyst's my favorite. So they often work on projects like, they do things like data cleansing and validation and quality assurance, the visualization of data, and various reporting projects, depending on where they're assigned. They'll create dashboards and reports that help teams track performance metrics and identify trends. Some common projects will be things like data validation, making sure the data is accurate and complies with the governance rules, is measurable, and those sorts of things. Exploratory data analysis, investigating data sets, large data sets about product information, customer information, and then also some KPI reporting, right? And you may even identify some trends that give you an idea for what a new KPI might be, something the company hasn't considered before. You'll also help ensure data integrity and provide actionable insights to various departments. So you'll actually generate the information that says, hey, look, this has happened. As a result of that, we now know this, or we believe we should that. Obviously, your skills are going to be proficiency in SQL, high proficiency in SQL. Data visualization tools. Make sure you know things like Tableau, Power BI, and obviously using spreadsheet software like Excel. And a strong attention to detail. I mean, this is key because there's going to be so much data that you need to really weed through and sort out, needle in a haystack type stuff. Look at the little blips, look at the minutia of information and really understand what it all means. And then of course, you'll need to be able to communicate those findings clearly. And that's often going to take the form of a dashboard, a data visualization that renders a story based on the data that you've collected in a way that others can interpret. So some example tasks would be develop reports to track user engagement with Meta. Those are going to be some important metrics across the products and all of their features as well. Just because somebody's using a product doesn't mean they're using every feature. You'll need to help product managers understand the behavior that you're seeing according to the data and use that information to make data-driven decisions. So being a data analyst, in addition to just knowing how data works and being able to manipulate it and render it and aggregate it into information that makes sense, you'll need to also be able to tell that story with a visualization, with a report, with properly calculated KPIs, so that the decision makers can understand what's happening and what they need to do next. Being a data analyst at Meta is going to involve working with very large data sets, so you'll also need to understand how to manipulate those effectively and efficiently, right? And last but not least, the data scientist at Meta, typically focusing on building and implementing machine learning models, conducting A/B testing, and analyzing the large data sets to extract those actionable insights. Usually they're working on the more complex statistical analyses and predictive modeling. So they're really using all that math to render information, not just aggregating it and reporting out on metrics, but actually pumping the numbers into models that then output what might be. So some common projects for the data scientist at Meta is going to be, developing recommendation systems, performing sentiment analyses, and optimizing algorithms for better user experience. Every algorithm takes a certain amount of time to process based on how it's calculated, and the more you can reduce that down, the better experience it's going to be for the user. Skills in this role, in the data scientist role, are going to be statistics and all that math. That's going to be really important, as well as machine learning. You'll need programming languages, not just the SQL. You will need SQL because you need to learn how to work with data, but you'll need to learn how to work with data in additional ways, such as using Python or R. These are strong statistical programming languages that help manipulate data and render decisions. So, big data technologies like, besides SQL, there's going to be Hadoop and Spark and some of those bigger ones that help you really work with enterprise level information. So some example tasks are going to be things like designing and implementing A/B testing. That's going to be a big one. Working on those machine learning models to help interpret information faster, more intelligently, more creatively. Analyzing the impact of a new feature on user engagement. That'll be a big one. And suggesting improvements based on some of your models. How could we do something better? How could we be more efficient at it? How could we work this out faster? So in general, with these three roles at Meta, the business analyst, the data analyst, and the data scientist, you're obviously going to need to understand how to work with data, writing SQL, leveraging spreadsheet technologies, working with data visualization. There may also be a lot of math involved. You'll be working on some sciences, especially with the tools like Python and R. At Meta, you're going to be expected to work with really large data sets and process that information efficiently and effectively so that you can provide meaningful insights to drive business decisions. All right, let's go over it in detail. To ace the SQL interview at Meta, you'll need to master a wide array of skills, including SQL, obviously, lots of concepts, and lots of analytical thinking as well. Meta looks for candidates who can write efficient queries, handle large data set, very large data set company, lots of information, and provide actionable insights based on that analysis. So to break down some of those skills that you're going to need, there's obviously the basic SQL queries. You need to know how to write SQL, and you need to be able to process data in a structured way by querying it with a language, SQL. Also some advanced SQL techniques. So it's not just querying the information and aggregating it and grouping by it and summing it all up. You'll also need to learn how to work with subqueries, window functions, lots of calculations and data manipulations with your queries. So it's going to go a step beyond. And not to mention, you'll also have to work on performance tuning. So your queries are going to potentially be large and expansive and cover not just a huge amount of information, but need to process it in lots of different steps, cleaning it and aggregating it, consolidating it. So learning how to analyze and improve your queries and their performance is going to be crucial, especially working with data sets as large as at Meta. So you'll also need, obviously, the data analysis. Now, we can talk about this and say you need to be able to use SQL, you need to be able to use aggregate functions, group by, halving clauses, right? But it's not just the analysis of the data specifically, it's how you think about analyzing that data. So you'll need to work on, your mindset that says, how do I take this information and manipulate it into something that makes sense? It's easy to look at a number column and say, let's just sum that up, or let's just average that out. But what is the meaning of that, right? What does this number mean, and what would each different aggregation render? What story would that tell? And also, what is the significance of the information? Is it relevant? Is it important, right? And how can we make a decision based off of that? And then finally, working with the really large data sets. I've said that many times, but this is Meta we're talking about, right? There's billions of customers. It's lots of information. Who knows how many transactions are happening every second? It's got to be incredible. Well, you'll know once you ace this interview, right? The other thing that I'll just add on to the end here is to say that Meta is going to be looking for somebody who doesn't just process the information, somebody who, writes a query and outputs the result. That's great, but everybody can do that, right? Everybody applying for the job can do that. What's going to make you different is being able to tell them, here's what you can do with the information, or here's how I can take the information and make it useful for you. So you want to have that business mindset as well. How is this valuable, right? I've worked with a lot of developers, a lot of analysts that simply wrote the query according to the requirements. But I've also had a lot of success in my own career by writing a query nobody asked me to write, because I saw a trend. I saw something that was interesting, and I queried it, and I calculated it, and I looked to see how could this information be important or useful, and then I brought it to someone and said, did you know this is happening? Did you know we could save this much money? Did you know we could improve our efficiency by such and such fold? These are going to be the things that really land you in that seat, all right? Is getting in front of the interviewer and saying, I'd love to be able to tell you this, that, and the other thing. All I need is access to your data. Now you're already confident, you're already ready to contribute, to be a member. It's just passing the skills test at that point. Let's talk about some of the advanced concepts you need to know to really ace that meta interview. Now, these are going to go beyond the basics of SQL, right? If you're applying for one of these positions, generally you're not doing that unless you already know how to query a database. But these advanced concepts are going to really test your knowledge, and you will be asked about these during most interviews with Meta or many of the other big companies, because they really evince your understanding of how data works and your ability to perform complex calculations. So I took some notes here. Let's take a look at a few of these and make sure we understand. So to start with, we're going to talk about window functions, right? So what are window functions? A window function is like a row number or a rank or a lead, or even some of the aggregate functions with window syntax like sum and average. They perform calculations across a set of rows in the table that are related to the current row. So again, row number, rank, lead, these are going to be comparisons, right? They're going to look at what's on this row and how does it measure up against other rows, maybe by order, by rank, by grouping. So understand what the window functions are, what the syntax is to do those. They're really tricky when you first get into them, but once you understand how they work, it's a snap and you can write them in your sleep, and they're going to be super valuable to you and very commonly used in deriving key performance indicators in your reporting and analytics. What about keys, right? What's a primary key? You're going to be asked that. So what is it? Primary key uniquely identifies a row in a table. It ensures that every entry is different from every other entry and helps maintain the integrity of the database. Rows need to be uniquely identified most of the time. The keys are going to help with the table relationships when you're joining data onto other data from a different table. Let's see here. Yeah, what about partitioning? That basically means to divide a database or a data set into smaller, more manageable pieces. It's basically like taking a subset of data and moving it over to another table or a temporary table or a view and making it more manageable and easier to use, first of all. But also it's going to help with your query performance, of course, because you're indexing a smaller set of data instead of taking the 1,000 rows that we have and with your where clause pulling out all of records that you want, which is about 100 of them, and then doing your aggregate function on that. You're only using a tenth of the data. So if you partition and you move that information, again with a table, a view, or even an ETL, then you have a smaller set to work on, so that when you want to perform that aggregation, you don't have to wait for a where clause to slice the data for you. It just ends up working a lot faster. So understand how to partition information, separate out what you need. Don't like to see these queries with 80 filters on them before they start processing their data. If that's the case, use a view, use a different subset, use a table, move that information somewhere else. Especially if you can, while you're doing that partitioning, limit the columns, the fields that you need, because then there's even less to process. All right, so we talked about some of the window functions like row number and rank. Do you know the difference between a row number, a rank, and a dense rank? Because it does come up, right? Okay, so row number, that one's obvious. It just orders the data rows and applies a number in the sequence based on where they fall according to that order. Keeping in mind that if you have rows where several of the columns are the same across multiple rows, you could get a different order each time unless you finally order by a column that's unique to those rows. Then there's rank, which is very similar. It orders them and gives them a hierarchy, but it does leave gaps when two rows end up tying, whereas dense rank doesn't. It closes the gap after ties. Well, actually, what dense rank really does is it ranks everything, and if there's a tie, it gives them the two rows the same value, and then it moves on to whatever the next rank would be, instead of rank, which leave that gap in place and say 1 and 2 tied for first place. Those are both 1. And then so the third record is going to be a 3, whereas with dense rank it would be a 2. That's what that means. And that can be important too. What about a recursive clause? So you should be familiar with a CTE, a common table expression, which is like a subquery. It's a smaller piece of the puzzle that you process before you run some of your main calculations. With recursive clauses, you can take the CTE and have it call itself. So you can recursively go back to the same information and keep adding on to it a certain number of times. So this is going to be useful for hierarchical data like org charts and tree structures. Also, we talked about views a little bit. Make sure you understand what a materialized view is and how it differs from a regular view. A regular view is just like running a query. Every time you request data from the regular view, it performs a query, and that query is going to need to be optimized, and it's going to need to apply indexing if it can in the database system that you're in, and it's like executing the whole thing every time you call it. Whereas a materialized view is also based on a query, but it actually writes it to memory. So it's not virtual like a regular view. It's almost like it's its own table, storing the data that has already been manipulated by the query that was written to create the view. A couple more topics. Let's talk about database indexing. So this is different than the indexing on the rows and how the database system reads those rows by scanning down the indexes in the order that it chooses to do that based on its programming. Database indexing is about how the data is actually stored on disk, and how do you link information to other information, and how does the database interpreter go out and find what it needs. So this is going to be, indexing types like etree, bitmap, hash, full text. Each one has a different use case depending on the nature of the data and the queries. It's not going to come up as often as some of these other topics because in general, the data architects and the database administrators will have already chosen how to do that based on which database they chose to stand up. But understanding how these work may help improve your performance. And that's going to be key at Meta is performance, performance, performance. These are large data sets. We can't stress that enough. Speaking of working with data, do you understand the difference between normalization and denormalization, right? So with normalization, it's about how you organize the data to reduce redundancy. So these are going to be forms, right? First normal form, second normal form, third normal form, voice cod normal form. Go out and look up Data Vault 2.0 if you haven't seen it already. It'll knock your socks off. But with normalization, you are making the information easier to write and easier to query, really, easier in its structure, easier to understand how it's structured. Whereas with denormalization, there is redundant data. There is, for example, instead of a table of customers and a table of their email addresses that are linked together on a related keys, you store in a table the customers with their emails, in addition to wherever else it was stored at sign up. But that's because having that denormalized table makes it easy to just read customer email. Done, right? You don't have to do a join in that case. You don't have to do additional processing. It's just right there next to the ID number of the customer. So that's going to help with simplifying query logic and increase read performance at the cost of write performance. It may lead to some data anomalies. These things do happen, but there are use cases for it. I know I've been blathering on for a while, but these are some of the advanced topics that you need to know. Now, for some of you out there, this is going to be a list of things that you need to go look up and practice with in your home environment. That's fine. There's nothing wrong with that. It's not that you can't get in without these skills. It's just that if you really want to ace those interviews and get into that high-paying position, which that's why we're here, right? These are going to be the skills that set you above the rest. For those of you who do know these things, make sure you've got them down pat. Go practice them. Make sure you understand what they are. Print out some questions based on the things I just said and actually have friends ask you to explain them, like flashcards, like you're studying for an exam. They are going to ask you some of these in the interview, and it's not necessarily that in every interview you'll be asked to construct one of these right there on the fly, but you will be asked to explain their distinctions and their nuances, or at least a couple of them, not so that they can make sure you know this way to do it, but that you have the skill. They're not going to say, why do you write it like this? They're going to say, do you know how to write it? And they're going to ask you to prove that by explaining how these things work. So go out and practice these skills. These are really important. And for the bigger stuff, data analytics, especially the data science stuff, you'll need to know these things, not only because you're going to be working with large data sets and that's difficult, but because some of these advanced calculations are going to be necessary for the kinds of metrics that you're going to need to be computing, especially, again, on those large data sets. All right, now we're going to talk about the coding portion of the interview, where you will be asked to write SQL code to solve problems presented to you by the interviewer. Before we jump in, I just wanted to show you this list here. I always preach this stuff. When you're going into your coding interview, remember, ask questions. Don't immediately start typing code. They'll think you have assumed you already know the answer, and they know you don't. So ask questions. What does this mean? What is the relevance of this? What is the structure of this table? These questions not only help you solve the problem better, but they also show the interviewer that you're thinking critically and you're trying to fully understand the problem before you jump right in and solve it. No assumptions. Don't think you know everything about a table. Don't think you know which column is the primary key, which one is related to the key performance indicator, which one is unique, or anything like that. Just don't assume, ask. You will normally, in good shop, have some kind of data dictionary, perhaps built by a data governance department, that will explain to you how these tables are built and how they get populated with data and where that data comes from. But you're not going to have that during the interview. You're not always going to need it, but you may want it because it may help you solve the problem better. Check yourself. Definitely check yourself. Okay? Don't just write the code and then say, there, I'm done. Go back and read it. Did you put a period in the right place? Did you put a comma or a semicolon in the right place? That sort of thing is definitely important, and it gets missed all the time. But it's not just about getting accurate code on the screen. It's about demonstrating to the interviewer that you are capable of performing a review of code, even your own if necessary, and making corrections. These are valuable skills that you need to have. Okay, you'll be correcting your own code, which you want to do before you submit it to production, of course, and you'll be correcting the code of your peers and your colleagues, and they want to know that you'll be able to do that. Be creative. Don't go for the instant solution. Don't go for the simple query unless it's elegant in its simplicity. Go ahead and use something complicated. Go ahead and use something interesting. Yes, you can solve this problem with the right join. You could also do it with a windowed function. And if you're not going to do that, at least explain the alternate ways that you may have been able to solve the problem. And finally, fear nothing. And this is general advice for any interview. But really, you're going to go into this knowing how to write SQL. You're going to go into this interview knowing how to solve these problems. You're just going to be presented with them brand new, which means you're going to need to take a moment to really evaluate what you're looking at. These are not timed interviews, so that's fine. But remember, you know what you're doing. You know how to do this. So you can solve these problems. It's just about, can you do it on the fly right then and there? And the interviewer is going to know that you're not surrounded by the normal list and litany of tools that you'll have. But if you do encounter something that they ask you to do and you can't do it, that's okay. If you can explain why you can't, or explain what you would try but you're not sure that it would work, that's still good, because chances are you'll have already said a lot of other things correct during the interview, and they've simply discovered where your cap is, where your limit is, and how they'll need to coach you should they bring you on. And by the way, if you're afraid of not being able to do something that you're not able to do, you're wasting your time. Because if you can't do it, they can't employ you to do it. But if you can do it, which if you're at this interview, that's generally going to be the case, all you got to do is write it on screen. So don't be afraid. And don't be afraid to mess up, and don't be afraid to get the answer wrong, because generally they will tell you, why don't you try it like this? Because they want to see you do it the correct way. Or they'll tell you, have you thought about this idea? And then you can try it again. And that's fine too. Nobody gets it right on the first try. And with that, let's look at a few examples. The first Meta SQL question, 2 different products, presenting us with a schema here. All right, what do we need to do? Write a query that returns the name of brands that have at least 2 different products, and its average price is greater than $3. Return the result order by brand name. Okay, so they're giving us a picture of the table here, what it looks like, what's in it. First question that I have, and the first thing I would do is turn around to the interviewer and say, which column is my primary key? Are there any constraints on any of these columns? These are good questions, right? For example, product ID looks fairly obviously like the primary key, but could another listing for product number 5 be placed in there with a different brand? Is that possible? Is it possible for a product to span 2 brands? If it's not, product ID is probably the primary key. But we need to check these things. And again, asking these questions of the interviewer will demonstrate that you're thinking critically about the information you're using, that you're not going into it with assumptions. One approach we could take to this, brands that have at least 2 different products, like brand 2 and brand 3 here, is we could query this and just say, all right, count the brands, group by the brands. In fact, let's just try that. We'll select the brand name and the count of product IDs that they have. And we'll group by brand name. Okay, so we're seeing how many products there are. So we could do this, and then we could limit it to only those products that have 2 or more, and then we could limit it to price. But there's a much easier way to do this, and we only need the brand name in order to populate our results. So we can just get rid of this here. Select brand name from products, group by brand name. Okay, that's good. We're going to do a conditional clause, but it's not a where clause, we're grouping, so it's a having. Now, I threw the distinct in there because we believe the product ID is the primary key, but it's possible that it's not. And if the same product gets listed multiple times, we only want to show unique products because we don't want to say 2 instances of the same product, we want to say 2 products. And that is something that you would clarify with the stakeholder. By the way, if you explain to your interviewer what I just said, they will be impressed because they know that you're thinking about the person who asked for this data and what the meaningfulness of the data is to them. Now, we also need to make sure that the price is greater than 3, which we can go here, average price. So we need to get rid of brand 3 because its price is not greater than 3, it's equal to 3. So we'll just move that to our having clause, greater than 3. Now we have our solution. If we check the answer, great, we're accurate. You see how I did that? It's just really quickly just pull out the brand names, group by them, and see how many distinct products they have, average out all those products, and use those as conditions, slicers for your data. And you're done. That one was simple. If I hadn't explained it as much as I did, it would have taken under a minute, which would look very impressive. Next up on the Meta SQL interview, promotion effectiveness. We've got 2 tables being presented here, orders and promotions. Promotion ID, probably going to be a validation table. It determines what values are allowed in the orders table. Let's see what we're doing. To increase sales, the revenue department runs various types of promotion. The revenue manager would like to analyze the effectiveness of these campaigns. So you're being given some context here. That's important. Pay attention to that. Write a query to find what % of the orders had a valid promotion applied. Round the result to 2 decimal places, and here's our hint. An order is considered a valid promotion if the promotion ID exists in the promotion table. So there you go. It is a validation table. So the first thing that I'm going to start off by doing is saying, let's see, what % of the orders had a valid promotion? So we need orders, and we need orders with valid promotions. So we are going to select from our orders table, and what we'll do is we'll left join the promotions so that we get basically, in fact, we'll just do a select star here and show what that looks like. So we get all the order information, and then over here we get another promotion ID, product ID, promotion ID. Oh, what did I do? O star and P star. Okay, so we get product ID, promotion ID is right there, and then we get another promotion ID added onto it if it's there, if it matches. And you see sometimes it doesn't. 1000 doesn't match. It's not in this list. So now we can do some simple group bys, or rather some simple aggregates, and just call this done. What we'll go for is a count of the valid promotions in that column that we pulled in by our join, and we'll divide that by a count of the customer ID. And I'm using customer ID because we know that something's got to be populated for this table to exist. There has to be a customer to an order, but that is a question that you could ask. And what I'm going to do is I'm going to multiply this by 1.0. Why am I doing that? Because I need to make this number a float instead of an int in order to perform division with decimal precision, which we're asked to do. We're asked to round the whole thing by 2, so we'll do that. Round the whole thing by 2. Okay, so 0.57, and if we check our answer, oh, it's not right because I didn't give it the right title. There we go. Oh. Typos are okay. Everybody does them. Even the person interviewing you is going to see you hitting backspace and know that it's familiar. Don't be afraid of that. So here we just did something really simple, right? We took our list of orders. They have promotion IDs in them. We joined the validating promotions table on that promotion ID to say, if you have a value from this join, which we will count up, and nulls don't get counted, then we know those are valid, out of, divide by, the total number of orders that we had. That's going to give us our percentage of which orders out of the total orders had valid promotion IDs. Very simple, very straightforward, but it's important to know how to do these divisors and to do these validators. Now, when you're going into this question, you may want to turn around and ask the interviewer, what is this data going to be used for? How is this going to be valuable? You don't really need to know, but you want them to hear you act. It's going to show interest, engagement, and a dedication to the solution. All right, let's get to the next one. The next Meta SQL question. Get the percentage of interactions. So we have an interactions table here with 2 different users and the date on which they were interacting. We want to write a query to find the number of users that 5 or more interactions in the last day, that had 5 or more interactions in the last day. So everything is in the last day, it looks like, so we're not going to have any trouble there, but we are going to apply the filter anyway so that the query is dynamic. And we need to look at both columns, user A and user B. So if I do this, select user A from interactions, where the interaction date is greater than or equal to the current date minus 1. That should get me all of user A. I just need to do the same thing with user B, and I'll union all of them. Now, why am I doing a union all? Well, because I want to stack the user A column on top of the user B column, which is what I've done here, about 24 records of all of these interactions, so I can see all of the users that had interactions. Now, I made this quick jump because I've done this kind of thing before, but you may be tempted in the interview to ask, do you care about conversations that go both way, sender and recipient? Like, is that important? Because these may be integral. For example, one of the common interview questions is about airlines, and they want you to find distinct routes, and they say, we don't care which direction it's flying, the route is designated as between 2 airports in either direction. So you need to be able to make these distinctions. But this will give us all of the users that had an interaction, and we'll put that in a CTE so that we can select our user, we'll call it user IDs. That's just the same thing. Okay, now what we want to do is we want to look at users that had 5 or more interactions. So if we group by the user IDs and say having count of user IDs greater than or equal to 5, we should just end up with the user IDs that had at least 5 interactions, and we did. Now, under normal circumstances, this would be a perfectly satisfactory output because you could load this straight into a visualization and let the chart aggregate the key KPI. But because they want to just know the number from the result of the query, we will wrap this up as a subquery or another CTE and say select a count of the distinct, well, it's already distinct because it's grouped by user IDs from the whole rest of this stuff. Now we have our number. We check the answer and figure out what column title we need it to be. Normally that would be in the spec. And we have a nice working solution here. It's just not like in the column title there, but basically all I did was say every user in either one of these columns counts as having had an interaction. So I'm just going to stack them together so I can aggregate them. And I aggregated them once to use the having clause to see how many of them had at least a minimum amount. And then once I got that list of 2 users, I just aggregated it into the number they wanted, the KPI, which again would normally be done with a data visualization chart. But the one thing I want to point out here is just a quick little union all, right? Effectively, we don't want to do a union because that would reduce duplicates. So we do a union all so that we get all rows no matter what it was in either one, and that gives us our list of users that had interactions according to the correct criteria. Okay, this is a fun one. Meta SQL question. Find customers who bought 2 brands. So we have our orders table, we have our products table, and our customers table. Interesting enough. We're considering running a promo across brands. We want to target customers who have bought products from 2 specific brands. Write a query to find out which customers have bought products from both the brand 1 and brand 2. Order the results by first and last name ascending. Okay, so we've got some orders here. These are the customer orders with promotions, units sold. Okay, cool. Products, these are the products that they're buying. Product ID, probably the relational key there. And that shows us the brand information and then the customers and what their information is. So what do we need to do again? All right, order by first and last name. We're going to show the customer information. So what we'll start by doing is we'll say select from customers. Go back and look at it. Customer ID, first name, and last name, because we know we're going to need, and now we need to get the product and order information so we can get to the brand names. So what we'll do is join orders on customer ID equals customer ID. Now why did I do an inner join there, just a single join? Well, because I don't care about any orders that aren't from the customers that are in the customers table, and that inner join helps filter out anything I don't need. And then what we'll do is we will join, let's see, we'll look at the products again. Yeah, we will join products on the product ID equaling the order product ID. And the brand name being in one of our 2 hard-coded brands. Now notice I put that condition in the join. Effectively what I'm doing here is I'm saying, give me the customers, add on the orders. I only now care about records where a customer exists and an existing customer placed that order. And then I join the products information on there to say, I only care about orders with products that exist. So the product ID has to match something in the products table. And it also has to match one of the brand names I want to filter on. Now I could have moved this to the where clause, but I just like to do it in the join because it's an effective way of saying I don't need certain rows. So, have fun with that, do with that what you will. But if we look at this, let's pull this in here too because we're going to need it. The brand name, it does exist right there. Oh, I misspelled it here. But see, I was able to correct that mistake without having to turn and ask for help, and that's good. They'll like that you're able to do that. So now we're looking at all our brand 1 and brand 2 ordering customers, and there are some duplicates because they've ordered from multiple brands. Some customers order from each brand. There's nothing wrong with that. We're going to play with this, so we'll put it in a CTE, and I like to indent my CTEs for readability. And let's see, we need to get customers that have bought products from both brands. So what we have here is a list of customers and which brands they've bought from, but we need to know, have they bought from both? So we will select the customer ID, first name, and the last name, because those are the ones that we need, from our CTE, where the brand name is equal to brand 1. And we'll do that again with brand 2. And that would give us a list. If the customer is in both of these results, both of these query results, it means they bought both brands. How do we make sure that a customer is in both of these results? The intersect statement. Except and intersect can be your friends. Effectively, what this is going to do is say these 2 queries are the same. They have the same columns and they're coming from the same CTE, although that's not necessary. But they're going to be 2 different lists. And intersect says, give me the results that are in both lists. And it looks like we only have one, so if we check our answer, that is correct. So except and intersect, if you haven't used them before, go look it up because they're very valuable. Except allows you to find rows from one query result that are not present in the other query result, and intersect is the opposite of that. It shows you the ones that are the same, the center of the Venn diagram. Very useful tool, and you will be impressive if you use it correctly. I have written queries that combined multiple intersects and except over and over and over again to filter through data. It can be very handy and just really fun. All right, let's do the last one here. Meta SQL question. Showcase the post rate for all time. We've got active users and we've got action. Your manager is about to go into a meeting with the event director and asks you to write a query to showcase the current post rate for all time. Quick, get this done. Please round to 2 decimal places. So we have a list of actions and active users here. Let's see. Well, we're just doing this for all time, so I don't think we need to use the active users. And the date field's not going to come into play here either, nor is the user ID, because really what we're just doing according to this criteria is we're just doing the post rate, the number of posts against the number of total actions. Now, you could do something here with a bunch of subqueries where you count up the number of records where the action is equal to posts, and you use a where clause for that, and then you do another subquery or CTE where you count all the records, and then you take those 2 values, you join them together, and you divide them. There's actually a quick and easy way to do this, and that's why I wanted to work on this one here. What we'll do is we will select from actions, and this is going to get fun. Watch this. Okay, we're going to sum a case statement. When the action is equal to post, then 1, otherwise 0. In fact, let's just look at that real quick. So we have 1s and 0s for whether or not it's a post. All right, guess what? If we sum these, we get the number of posts because only the posts have a non-zero value from our case statement. And if we count them, we get the total number of actions. Do you see where I'm going with this? So what we'll say is a sum of the ones, sum of the posts, divided by just a count of any record of all records. That should give us our post rate. But wait, we need to round it to 2 decimal places. So we will round all of this by 2. And we're going to multiply this count by 1.0 in order to get that float in the denominator there that's going to give us our decimal precision, which we will then round to 2. As the post rate. So we got 67%, and that's accurate. So this was pretty quick and easy, and normally, you know, ad hoc stuff that you're just asked to do while somebody's standing at your desk because they're on their way to a meeting will hopefully be this simple, and it will be based on tables that you are familiar with already, so you can quickly run one of these, may even have a canned query ready for this kind of question. It's on the interview setup because it is actually pretty simple and straightforward. You don't need to use anything except the 1 column, action. And if you can sum and total that up and figure out a rate without having to do multiple joins, you're gonna look pretty impressive. Preparing for a Meta SQL interview can be daunting, but I've got some tips to help you succeed, and you combine this with practicing writing SQL regularly, as I mentioned, which we just did a moment ago, and some mock interviews that you can do with people you know, and you should be set up for success. So to start with, just as a general preparation step, make sure you know the process of the interview, that you know who you're talking to and what you're talking about and how long it's going to be. They should give you a general time frame, probably about 45 minutes. There will be some questions. They'll want to get to know a few things about you, and they'll run you through the coding exercises, and then afterwards there may be some follow-up questions. Another thing to think about is that the coding interview portion that you'll have just done is not necessarily the full interview. You may still end up meeting with the hiring manager to discuss the role and how you would fit into it, or more specifically, how you would fit into their team. So the coding exercise, the coding interview, is really about making sure you have the necessary skill set to join. Then they get to interview you and find out if they actually want you to join. That's where you convince them. Passing the skills part, the SQL coding interview, is great. Just make sure you're prepared for that potential second round, and take a moment after the coding exercise to ask the person who's administering that if there's anything that they should know about the team you'd be joining or the hiring manager you'll be meeting with. And that demonstrates some engagement. It shows them that you're curious, you're interested, you're paying attention. These are all good things. Another general tip is admit when you're unsure. If you don't know something, I think I mentioned this a few back, but go ahead and say so. I'm not exactly sure how this would be done, but I know that you could solve it with XYZ, and I just have to look up how to do that. Or I've never used this particular tool before, but it seems like something I could learn easily. Always cap it off with a positive, because they'd rather you admit to not knowing something than try to obscure it. That's a bad quality to have in an employee, so you don't want to demonstrate it during the interview. So for the coding portion, a few things. Practice. Get on big tech interviews, get on whatever platform you may be hosting at home where your databases live, SQL Fiddle websites, that kind of thing, and write code that works. Dedicate regular time to studying it. Most of us stay sharp because we're doing this every day on the job. You need to continue staying sharp while you're between jobs or while you're looking for your next job, and you need to be expanding those skills as well. Another thing is breadth over depth. It's great to go into strong detail explaining all the tiny nuances of how something works or why you did it the way that you did it, but in general, with the coding interview, you'll be talking to someone else who's technically minded, and they'll know what the answers are. They'll know how these things work. Explaining that you know how they work is great, but showing off that you know a lot of different ways to make it work is even better. So cover a lot of ground if you can. Right? Try a lot of different solutions. Certainly explain why you did something the way that you did it, but focus on the advantages of how you did it over perhaps what other options may have been. While you're doing the coding interview portion, think out loud. Not only is this a good tactic for keeping yourself on task and making sure that you have the right kind of conversation with yourself to really troubleshoot and problem solve, but it gives the interviewer the opportunity to correct you when you don't know. If they feel like you're going down the wrong path, there's a chance that they will course correct you to see if you can solve the problem. And that represents going to management for help or going to peers for review. So think out loud. That way, not only will they be able to help steer you in the right direction, but they'll at least know what you're working on in your head, instead of just watching you sit and stare silently at a screen. Besides the fact that talking out loud might help you get to the solution faster. And then lastly, when you're doing the coding, simple is key, right? Keep it simple. There are a lot of complex solutions. With some of the ones I did on screen, you notice that while there were other methods to do it, I managed to accomplish the solution in 4 or 5 lines of code. And if you can do it simply, do it simply. Simple code lives longer, lasts better, performs under pressure, and can be easily interpreted by the next developer who needs to come by and take a look at what you were doing and add on to it, or even fix it. So keep it simple. I like to advise to show off and do complicated things, but only if you can do them simply. And when you're doing the actual design interview, the portion that's not necessarily writing code, but where the hiring manager is interviewing you, or the second half of the coding interview, you may be asked some questions like, we have this problem, how would you solve it? Or, talk about a time in the past where you've approached this kind of issue. So a couple of things on that. Break down the problem, ask clarifying questions, and identify what are the main goals, what are the critical issues, and what are the constraints. The reason you're doing this is not only so that you can create a substantive solution to their problem, but to also demonstrate that you're capable of thinking analytically. You may be capable of coding analytically, but can you think analytically? That's something they need to see as well, especially at a big company like Meta. The other thing is, when you're coming up with examples from your past, be specific, but don't go into too much detail. You want to make sure you demonstrate things like the STAR method. What was the situation? What was the task that you performed to respond to that situation, or the task that you designed? And what was the action that you took to enact that task, or that happened as a result of your task? What was the result? STAR, S-T-A-R, result. Go into detail. And it seems strange to do so, but coming up with examples of high priority or high volatility or something, tasks or solutions or projects that you worked on in the past, writing them out on the STAR method so that they're fresh in your mind when you go to that interview, that can be really helpful. Also, when you're talking about solutions, you want to evaluate, well, okay, so what's the trade-off, right? What kind of benefit, what kind of solve am I granting here, but what's it going to cost us to do? I have always approached problems with multiple solutions when I go to the decision maker or the stakeholder and I say, you can do it this way, and that'll solve your problem for about 6 months and it'll be cheap. If you want to solve it long term, it's going to be more expensive. It'll take a little bit longer to do. There is a middle of the road option as well. So if you can do that, definitely do that. And, take a holistic view to what they're telling you and how you're responding to it. You want to transition smoothly between high level and low level design, right? Explain that your solution would solve this problem by, and then add a couple of points for how it would, bullet points for how it would solve that problem, and then move on. Go back to solving the solution. Don't get too lost in the details. Make sure you demonstrate that you understand what the problem is and why it needs to be solved. And even if you have to ask the clarifying question, what the eventual goal is. It's one thing for somebody to say my computer's broken, right? And you can say I'll fix it. But ask, what are you using this computer for? Do you maybe need a different one? Could we replace it? If we get it to boot back up, do you only need it in terminal mode, or do you need the desktop environment, or that sort of, there may be multiple solutions. Lastly, there's also going to be a behavioral interview. So that's going to be mostly with the hiring manager, where it's an actual interview. Like, they are wanting to have a conversation with you to sort of get to know you, figure out who you are, what you're like, if you're going to be a good participating member on their team. At this point, you've likely already passed the coding interview, and before that even, the recruitment barriers. And now they're trying to find out, since you're a viable candidate, are you going to work out here? And while you're doing that, a couple of things to remember. Okay, first of all, know your resume, because they are going to ask you about your background. They're going to want to know about your past projects, explain any gaps in your employment, make sure that you can demonstrate those past projects like I mentioned. They're also going to try to feel out whether or not you would be a contributing member of their team. So watch for questions that ask about how you react to things, what your impression of stuff is, and examples of how you worked on a team in the past. Feel free to ask them a few questions too. So, what is your team like? What's the atmosphere? What's the culture? Don't just blurt that right out. Wait for an opportunity to bring it up. But hopefully by the time you get to this point, you'll have had a chance to figure that part out, and you can start to describe yourself as a person who would fit in nicely with this environment. And lastly, and this one comes as a shock sometimes, but be honest. Tell the truth about where you've been and what you've done, but also tell the truth about where you haven't been and what you don't know. Not every hiring manager is going to look at a gap in something and say, well, clearly this person can't make it. A lot of them are going to look at it and say, that's something I can train into them. And what they're not saying is, that's something I can train them to do the way I want it done. So that'll happen. But the other thing is, if you don't actually know something, it's going to come out. I mean, we're talking about Meta here, and they have put you through multiple interview phases at this point, including a strenuous code exercise. They're going to know if you don't know something, or they're at least going to suspect it based on your demonstrated skills and your background. So be honest, explain, well, this, that, and the other thing. Somehow you've managed to thrive and succeed and still be who you are up to this point. So whatever you didn't know didn't stop you from sitting in front of that Meta hiring manager. So you can do it. You just got to explain to them, I've used alternate solutions, or I haven't encountered that scenario before. I've been in the data science game for over a decade, and I only learned Python last month because I didn't need it. Didn't need it in any situation I'd ever been in. Sat next to Python developers and raced them to solutions, wrote SQL and beat them to it. But it's what everybody wants now, so I've taught it to myself. And now I'm writing Python apps and scripts right and left. I explain that to people all the time. I'm very adaptable. I can figure things out. When I got my first SQL job, I didn't know SQL. So I went home Friday night, studied SQL, came in Monday, wrote SQL scripts, and it just built from there. That's me being honest to a hiring manager. And they like that. And they like to see that you've got that tenacity, that willingness to admit where your faults are, but the drive to try to succeed anyway. So that's a lot of information, but just to recap, we'll say you're going to have the recruitment phase, you're going to have the coding interview, which we just covered a bunch of examples that I processed on screen. So practice, practice, practice. And then you'll get into that hiring manager interview, which is really a behavioral type thing to see if you would be a good fit with the company culture, with the team you'd be working on, etc. And make sure that you prepare, practice, rehearse. That's basically the same as both of those. And again, be honest, be simple, be straightforward, focus on solving the problems that they have. They are going to put money down under your name. They're going to write a paycheck in your name in exchange for solving some problems that they have. Focus on doing that. You'll be fine. And that's a wrap on our guide for acing the SQL interview for a Meta data analyst or a Meta data scientist. If you found this video helpful, give it a thumbs up, share it with your friends, leave some comments below about topics you'd like to see covered in the future. Remember, consistent practice, said that enough times, practice, and understanding key concepts. These are going to be your best tools for success. Make sure that you're prepared and go in with confidence. So good luck in your interview preparation, and I'll see you in the next video. Don't forget to check out these videos and subscribe to our channel for more tech career tips and tutorials.